pool table of size 6 by 4 has 4 pockets, one in each corner of the table, and no pockets anywhere else. You set a cue ball down right in front of the pocket in the bottom left corner of the table, and shoot it at a 45-degree angle across the table. It will continue rolling until it drops into one of the corner pockets. Can you predict what corner the billiard ball will end up in? How many bounces does it take to get there? We will assume each side of the pool to be a mirror and the path of the ball is a ray of light. There are 4 corners, one in each corner of the rectangle, none on the sides. A ball modeled by a straight line is launched at 45 degrees from the bottom left corner, which means it cuts through every square of your graph paper exactly along the diagonal. What happens when it hits the side of the table? The answer is that it bounces off at the same angle and continues along the diagonal of the square grids. We will assume each side of the pool to be a mirror and the path of the ball is a ray of light. While looking at an object in a mirror, we have the impression that the movement of the ball is behind the mirror. Once it hits the side of the pool, the blue will represent the light ray. The movement of the ball is behind the mirror. If it continues, the blue ray will keep on hitting the sides of the red square till it passes through the vertex. Simultaneously, the ball will drop on the left top corner pocket.